I think it really comes from understanding from our customers what's meaningful to them. It's very easy to sort of innovate in a black box, and sometimes things the team will come up with look scientifically interesting but don't necessarily translate to a meaningful improvement to the customer. So I think what's key for us is we spend an awful lot of time out with our customers in their labs, trying to understand what their key problems are, and then trying to understand what's meaningful to them. And sometimes that can be something very simple. Sometimes it's quite surprising, like you can make a simple change that completely transforms a workflow or a problem they're trying to overcome within their lab. Other times you can find that you can do an awful lot of work thinking you're actually making a meaningful transformation. It actually doesn't make that much of a difference to their overall lab environment. One of the things we've done over the last couple of years we think has really helped us is that we used to bring customers in right at the end of a project just before we're about to launch, show them the product, get their feedback. And there's not really a lot you can do at that point to modify the product. It more sort of tailors your marketing positioning. What we've done for the last couple of years is we'll bring customers in very early now. Even when we've got breadboards, once we can actually run an assay on an instrument, we'll start to bring customers in, show them the instrument, run their samples, get their feedback, and then we incorporate that feedback into the project. And then a little bit later on, we'll actually then deploy early breadboards of the systems into their labs once they're a bit more mature and allow them to run in their environment and then get the feedback and then again reiterate the project. That's made a huge difference. One example I'll tell you about with the launch we did for the Novus V55 is that when we introduced AEMRM, we thought that would be interesting, and it turned out to be like amazingly exciting to our customers that we had developed that and that we were able to generate that sort of level of improvement in assay speed time. And we didn't think it would be as exciting as it turned out to be. We thought something else would really catch their attention, and it turned out to be that was probably one of the biggest elements of the V55 launch.
Yeah, I think it's probably a couple of points. One, I think, is how we incorporate AI. Clearly there's a huge opportunity to, again, for the simplification and ease of use, to utilize AI instruments, whether it's the actual running of the method or even in troubleshooting. For example, with the new product, we have a brand new remote diagnostics and troubleshooting capability through the use of machine learning and algorithms to make it really simple for people not just to run the machine, but diagnose if there's a problem. And so I think for us, continuing that implementation of artificial intelligence into how the instrument operates. The second thing is automation. We need to look at the entire workflow. Again, the instrument is one part, and so we need to make the whole workflow highly automated through the use of auto samplers or the use of auto diluters or advanced rail switching systems. I think for me, it's that holistic view when looking at a workflow. If a customer is wanting to analyze seawater or drinking water, how do that entire workflow, and it needs to be automated. I go to some customers and they're telling me in the next 10 years, they'd like to completely see a dark lab. So there's no operators, no technicians. So I need to work out with my team is how do we develop instrumentation that can operate completely independently of operators. And that really comes down to the automation, the software, and that's almost the next field for us to fully explore. There's no doubt in my mind that that's where our customers are going, and we need to be able to support them in that.
It's happening all the time, and I would say for this conference, for this year, there's a big historic shift happening due to innovation in moving from small peptides to whole full-length proteins and proteoforms. And that innovation is, we have to innovate to get there.
I still think there's a barrier to adoption of mass spectrometry. I mean, it still is. We often refer to sometimes in the industry as the cult of mass spectrometry. Like they are still highly complex instruments to use, and they require a certain degree of know-how to use them. Now, it used to be, certainly when I started in the industry, that people would hire PhDs to run mass spectrometry. We had PhD in mass spectrometry, and that world is changing now. And now most of our customers have a PhD in another field, and they happen to use mass spectrometry as a way of getting the answer to help them in the field that they're studying. And I still think that's probably the biggest gap right now. I think over the years, all the vendors have been improving on the performance of the instruments, increasing their ease of use, but the software still, we all have our own proprietary versions of software, our own sort of software ecosystems, and there still is a barrier to adoption. around that. So I think that's still the biggest opportunity for all the vendors, is to sort of continue to innovate on the software side, to sort of transform that user experience. We're super excited about AI and using sort of natural language interfaces as a way of transforming that user experience. And I think that's going to happen over the next 5 years for sure.
I would say there are various constraints, right? We are on an annual cycle of product releases. Every year things get better. I would call it like the iPhone dilemma. You just bought the iPhone, the new one comes out. So you got a capability, a cost point, business economics, and what helps you advance science. So the question should be, if you had unlimited resources and finances, how would you advance science? So somewhere in the middle is where that answer lies, I would say.
Yeah, so one of the gaps really is we're generating more and more complex data, and yeah, that's because that's what customers are demanding. That's what we need in order to be able to gain deeper and deeper insights into biology. Is getting much more complex data, whether that's data coming off of imaging, as we talked about before, or whether that's our cyclic eye mobility data, which is again incredibly complex data. So really the key is the ability to interpret that data, to be able to translate that into meaningful insight, which can then be used to make decisions that will help the researcher or the clinician or whoever it happens to be that's using the instrument. So that's where a lot of our development is going, in the area of data interpretation, again using AI models to help with that and really to speed up the entire process.
Gaps, or if you want to call it opportunities, what I see is in the research environment you drive cutting edge science forward and set up the methods and the workflows in a way that you can address these research questions. But the next step is to standardize these workflows and make them, let's say, routinely available in other labs. And I think this is where I would say we have opportunities. And this is not only in the mass spec side, it's mainly across the whole workflow when it comes from sample prep to separation, to mass spec detection, to data processing with AI or other tools.
I think, yeah, certainly the funding environment has changed globally, and it's been challenging in certain geographies, putting pressure on individual academic labs, core facilities. Certainly the expectation today is that instruments do more, right? They cover a wider variety of applications, they're more versatile, and they have to be ultra robust so that they can withstand changes in application from day to day. That's certainly an expectation that Bruker has felt over the years, and it's certainly a need that we aim to meet for our customers. So each of our instruments is a workhorse and not what we call a one-trick pony. Even systems like the TIMS Metabo can do proteomics, for example. Even though it's really specialized for one type of omics, it can do other omics. So it's a good, solid investment there for budget-constrained laboratories.
So it is incumbent upon vendors to be exceptionally customer-centric. If we're not doing that, then you're not meeting their needs, and that what money they do have to spend, they're not going to be spending because they don't see the value in it. Here at Agilent, that's our main focus. Customers number one. Understanding your customer, what their needs are, and delivering value to them is how we can help them do their job and ultimately help our business.
I think what we see, especially in the academic and government area, we see flat and shrinking funding and delays in getting funding. What we see our customers doing is they prioritize because they want to continue their research, they want to drive their things forward, their science forward. So what we see them, as I said, is they prioritize, and we work with them, so to say, to make it possible to fit to their budget to drive their science forward.